Hi guys, it's Miss Richmond here. This is week 8 of the closure. Time is passing at such a strange rate. Sometimes it seems so fast and other times so slow. So I am on the mass to mole conversions document, the part 2 document that's assigned for this week. Yeah, it's week 8. Okay, I'm glad that I was right. So this week is going to be pretty similar to last, only this time instead of going the mole to mass direction, we're going to be doing the opposite and going mass to moles. So still two-step conversions, same conversion factors, mole ratio and molar mass. The only difference is this time we're going to be moving in the opposite direction. And I'm working on the video right now, which will ultimately be linked here in the Chem COVID-19 closure assignments document. Once you're done with this lesson and with this mass to mole conversions part 2 document, there's an open note quiz that's linked in your Chem COVID-19 closure assignments doc. It's on Google Classroom as well. So it's a mini quiz. It's just 4 questions. Again, it's totally open notes, so you can use anything that we've worked on, any of these documents, literally anything, slideshows, whatever, notes that you have. My only ask is that you work independently on it. It's honor code, so I'm trusting you. Yeah. Okay, I'm going to go through a couple of questions from the mass to mole conversions part 2 document. Just like last week, I think what I'm going to do is skip these beginning problems. So they give you an example of a mass to mole conversion where you're trying to figure out how many moles of H2 are needed to produce 34.8 grams of NH3. And they show you how they solved it. And then they're like, what's the given? What was the desired? Where did this part come from? Where did this next step come from? So I'll let you guys work through those on your own. What I'm going to do now actually is number 7 and 8, I think. Yeah, I'll do 7 and 8. And attend Google Classroom and you can see us work through the top part too. We'll do that as a group. Because again, this is supposed to be a POGL where you're supposed to be working in a group. Coronavirus made that less possible, but I want to still do it to the best of our ability. But I'm going to do number 7 and 8 using the balanced equation from number 6. So we're given this equation 4Fe plus 3O2 yields or produces 2Fe2O3. The first step is to determine, or not the first step, the first question, number 7, that we'll work on is to determine the molar mass of Fe, which is iron. And we got to use our periodic table. So I'm just going to open up my periodic table that I like using, that I can zoom in on. And I'm going to find Fe. Is my head blocking it? Oh, no, it's over here. I know, I teach chemistry. I've been teaching chemistry. I still do not have the periodic table memorized. That is okay. I don't expect you to ever memorize it. Okay. So 55.845 is our molar mass. Remember, it's the number at the bottom. I'm going to round that to, let's just round to 55.85. And that'll be 55.85, our molar mass of iron that we'll use. And the unit for that is grams per mole. And remember what that means is like there's 55.85 grams of Fe in 1 mole of Fe. Remember that 6.02 times 10 to the 23rd atoms. That's what a mole is, that scientist Avogadro came up with. And that's how much 1 mole of iron weighs, 55.85 grams. Okay, next question. How many moles of O2 are needed to react with 16.09 grams of Fe? So we're getting into our conversion problem now. So I'm going to be using my conversion steps that I have here in yellow. So step number 1 is to determine my given value and my desired ending unit, as always. My given and my desired. So my given here, in number 8, I am given this number, this quantity, 16.09 grams of Fe. So that's going to go in my given. And what I'm trying to figure out is moles of O2. How many moles of O2 are needed to react with 16.09 grams of Fe? Okay. Next, I'm going to draw out my map. These are two-step conversions, so remember we're going to go given, intermediate, desired. So we're going to have two sets of arrows, two full steps. So we'll do 16.09 grams FE. We'll have our middle step where we go from grams of FE to moles of FE. We can't compare grams of one substance directly to moles of a different substance. We can compare moles of two different substances. So that's why I'm first going to convert to moles of Fe, and then we will finally convert to moles of O2. First step, to go from grams of iron to moles of iron, we're going to use this equality statement that we already found. That's our molar mass. So that's going to go over this arrow. And then to go from moles of Fe to moles of O2, this is where we're going to be using our mole ratio. I'm just going to actually do some highlighting here. So let's pick two colors. Ooh, let's do orange and purple, DCP colors. So moles of Fe, I'm using this part of my balanced chemical equation. And then to convert to moles of O2, I'll use purple. And that's this substance in my chemical equation. So the way that moles of iron, Fe, and moles of oxygen, O2, are related, there's 4 moles of Fe, that comes from this 4 in front of Fe, for every 3 moles of oxygen. That's called the mole ratio. That's what stoichiometry is. At its core is just mole ratios and using mole ratios to convert as a conversion factor. Okay, let me get this all centered. You guys know I'm pretty anal about this. Okay, so this is the molar mass of Fe, and this is the mole ratio. I have this very particular format that I've been liking to follow for step 2 for drawing out the map. I just think it works well. Okay, so here's what I have now. Whew, that's step 2. We're on to step 3. The best step, just take your given value, the 16.09 grams of iron, put it over 1. The best step. Then we're going to multiply using, or solve using desired over given for every single one of our steps. And since we have 2 steps here, we're going to have 2 sets of parentheses with desired over given and then another desired over given. So first desired over given for this step here, to go from grams of iron to moles of iron. My desired for this first step is moles of iron. So I want part of the conversion factor with moles of iron to be on top because that's my desired. And then divided by our given unit, which is grams of iron. And then we're going to multiply again using the mole ratio, this second step, using desired, which is moles of O2 in the second step, over given, which is moles of Fe for this step, because we're like on that second part now. So we want the one with our desired on top divided by our given. And then we're ready to solve. So literally all you have to do, 16.09 divided by 1 times 1 divided by 55.85 times 3 divided by 4. It seems complicated, but it shouldn't actually be. Whatever your answer is, that's going to be in the unit of moles of O2. I'm not going to solve it for you again because I want you to do that. Come to Google, or not Google Classroom, come to Virtual Classroom this week if you want to work through the top questions, or if you have any questions about this that I can help you figure out. But this should get you started. Yeah. see you guys in virtual classroom, hopefully. Bye, Miss Richmond out.